Let me welcome you to the 9th lecture of surface mining technology. Before this we have covered the introductory part, and from here this lecture topic is opening through box cut. This is the first lecture on the box cut, there will be another lecture on this. So, the commencement of surface mining is carried out with the opening through box cut. So, basically we are also commencing our main surface mining technology class from this lecture onward. So, the title of this lecture is opening through box cut 1. As the requirement, let us show the learning background of the surface mining technology course, learning objective of the surface mining technology course, and what is our expectation from a participants of surface mining technology course. And these are the textbooks and reference books we advise the participants should go through. And this is the retrospect of the previous lecture. In the previous lecture, we have discussed the current status of the surface mining. We have discussed the phases of surface mining. We have discussed about the rocks and minerals also, and we have seen the process of decision making in the every phase, and an overall idea about the different surface mining machineries is also given in the previous lecture. So, we know what is an excavator, what is shovel, what is drilling machine, what is drag line. The glimpse of that is already shown in the introductory classes. So, the learning objective of this lecture is to have a general understanding about the deposit location, formation types, and to know the commencement of surface mining operations, to understand the importance of size, shape and location of the box cut, and the technology for excavation of the box cut. This is the learning objective of this particular lecture. This is already we have discussed, but as from now onward our mining has to be carried out, and that is why we should have a little bit knowledge about this deposit. We can have a massive deposit, we can have vent deposit, we can have bedded deposit. So, we can have columnar deposits also. So, this is a little bit idea about the types of deposits you always keep in your mind while you are following the surface mining lectures. So, what is box cut? Box cut is basically the first excavation made to the deposit for carrying out the mining. To the it is not actually to the deposit, it is the first excavation made to exploit a deposit by surface mining is called box cut. Now, what is in other way you can tell the box cut is basically the starting point for the formation of benches. That means, whenever we are carrying out surface mining, what we do? We basically form the bench to exploit the deposit. So, box cut is basically the first point to form a bench, or it is the starting point of the formation of a bench. Benches are essentially required for the horizontal slicing of the box. So, what is surface mining? Let us understand in a little bit way like this. Suppose this is our surface and our ore body is lying at this position. So, this is the ore body, and we have to excavate this. For that, what we carry out? We go for forming the bench like this. Okay. And by forming of benches, we exploit this one. This part we have discussed in our layouts, where we have shown how the benches are made. So, benches, you know, this benches is a rock shelf. So, we have carried out, and you can say surface mining is nothing but the horizontal slicing of the deposit. So, you can consider these are the slices. So, these slices are taken out gradually one by one for excavating. So, the first slice which is taken at this position, let us use a different color. This is the first slice which is taken out at this position is called box cut. Okay. So, benches are required to go for the horizontal slicing, and the first opening made is called a box cut. I think this part is more or less clear to you now. So, you can see this is the first initial cut made. This angle is showing, so that it can remain stable, it will not fall down at this position. So, this is the excavation, first excavation made in the in situ, and this is creating the box cut. In other way, you can say box cut is also the opening made so that we can go for lowering the machine into the lower bench. So, this excavation is made. So, this excavation is made so that we can lower this machine at this position. That means, this is giving us the idea that we have to create an opening in this place in such a way, so that the excavation should have sufficient dimension, so that these machines not only can be placed, it can have sufficient space for the operation. So, that means, a box cut has to be made, that is basically excavation of this much of volume, and this volume should be sufficient, so that machines can be lowered there and they can be used without any hindrance at this position. And what is the next? Next we basically extend this one, that is why our drill machines are placed at this position, so that we can excavate this one further. This is a photographs of the box cut. You can see the excavation is already made. This is the box is already made at this place. You can see this portion, we are making it ready for the blasting. Here the excavator is working, here the dumper is moving, and this is the dozer. So, all these machines are working here. So, the sufficient space is created at this position, but simultaneously as the machines are lowered, machines are working here. So, there should be some access, so that the machine can move, and this is the access. This is the access made here, and this is the ramp. So, that means, a box cut not only having an opening, it should have an access for entering into that lower level, and that access is called ramp. So, this is the essential requirement, essential part of the box cut, and this has to be remembered that a box cut is not only the ramp, a box cut is not only the opening, it is an opening along with a ramp. So, that must be remembered. So, in the plan view, what you can see, this is basically a box cut, this is the box cut, this is the opening made in the lower level, this is in the upper level, and this is the ramp. This part is the slanted one, this is the slanted part, and this is also slanted part. This is the angle provided for the stability of the benches. So, this is having the inclination which is required for the plying of the machines. So, you can say it may be in 1 in 12 or such. So, that means it is say 3 degree 4 degree, 3 degree 4 degree angle is in general provided, or maybe 5 degree angle is provided here. These are the slope of the benches. So, you can consider this may be of say 70 degree or 80 degree angles are provided in this position. So, this is the plan view of a box cut. If you look into the sectional view, I think let me come out of this. So, you can see the sectional view here. So, this is the sectional view and this is the plan view. So, this is the plan view, this is the sectional view. You can see this is the bench, this is basically bench and this is basically ramp. So, that our machine can ply on this, and this is the bench. So, that we can carry out drilling and carry out blasting here. So, for the better photographs, we have given a little bit more angle in this. Now, this portion we will discuss later on. This is the different segment. You can see the nomenclature, the surface points are named as the capital one and bottom points are named as the smaller one. So, the M is at this position, small m is at this position it is the capital M. Okay. So, capital M is excavated, that is why you cannot see the capital M here. Instead of that, capital M is directly on the top of this position, but so you can see the capital M somewhere in this position, but as it is in the same line you cannot see it, that is why it is showing in this way. So, this is the nomenclature shown in this. We will go into the details of this one at a later stage. So, this slant part is shown in this figure. You can see this part is a little bit slanted one, that is why it is the sectional view is given like this way. So, we are having say huge deposit, this is the surface, and say we are having a deposit like this. Now, we have to decide at which position we should place our box cut, whether we will place our box cut here or we will place our box cut here or we will place our box cut here. So, what will be the position of the box cut, that decision has to be made, and in this case we are having the option, either we can provide an internal box cut or an external box cut. What is internal box cut? If the box cut is placed vertically above the deposit, then it is called internal. If the box cut is placed not vertically above the deposit, but within the pit limit, it is called external box cut. What is the meaning of pit limit? Suppose we are having, this is the surface, and say we are having a deposit like this. So, the lowest point we are going to excavate is this one and this one. Now, to excavate at this position, we have to carrying out our benching. Say this is the benching. So, this benching is required so that our machine can ply on the benches and this portion rock will remain stable. So, this is the actually angle, slope angle, that slope angle has to be provided so that it will remain stable. So, this is called pit slope angle. So, this pit slope angle has to be provided so that the rock will not fall down here. So, this excavate this point, we have to excavate at a surface, this is the H depth. So, to excavate this point which is at a H depth, we have to excavate additionally this much of distance beyond the directly vertical point of the deposit. So, this is the vertical point of the deposit, but we have to go for additional excavation up to this. So, this point is called pit limit. So, this is the final pit layout when we are excavating. So, when we are excavating, this is the pit limit, you can consider this is the pit limit what we are carrying it, what we are excavating for extracting the complete ore. So, in external box cut, we are basically placing our box cut not vertically above the deposit. That means, if this is the deposit and this is the surface and this is our, let us draw pit limit in a different color. This is, if this is the pit limit, then we are placing our box cut, at this position, which is at this position, which is not vertically above this. So, this is here, it is not vertically above the deposit, but within the pit limit, then it is called external box cut. So, now you have understood that internal box cut, if the internal box cut is in blue color. So, this is the internal box cut and this is the external box cut. Okay. And this is the basic requirements, but some we are having some different idea also available, that we can have our box cut in the ore itself or we can have our box cut in the waste itself. So, obviously, it is understood if our deposit is like this, we cannot have a box cut in the ore, because box cut is the first excavation. So, we cannot reach here because it is at a depth. So, in the ore box cut is possible only when our deposit is exposed to the surface itself. In that case, we are having the option, we can go for placing our box cut in the deposit itself. So, this is a rare case, we can have option if the deposit is having the outcrop, otherwise in general we have our box cut in the waste rock only, and that is why whenever you are excavating this one, you should have the preparation that you have to dump this one somewhere in this material, somewhere outside the area. So, this is we will look into the different options. Say for the massive deposit, we have to go for the internal box cut, because if we are providing an internal box cut, we will reaching to the deposit very shortly, and that is basically the moment we are reaching the deposit means we have to excavate the main mineral and we can sell that and we can get the return money. So, that is very very important, and for that to early reach to the deposit, we are placing the box cut above the deposit vertically. So, that is why we go for the internal box cut. Same thing we can see for the vein deposit also, but in case of bedded deposit we may go for the external box cut. The reason is that if our bedded deposit is like this, what we would like to do, say deposition of this all this overburden material, transport and deposit it to some outside area required huge land acquisition. So, to overcome this, what we try to do, we try to carry out mining from one side, and after the execution, say this part is taken out. If we have taken out this one, then we may utilize this area. After taking it out, we can utilize this area for dumping of the overburden rock. So, suppose if our pit is at this position, say if our pit is at this position, in that case up to this is already excavated. So, this part can be utilized this area can be utilized as the dumping of the overburden rock, overburden dump. So, let me actually redraw this one. If this is the position of the pit, we are excavating this material at this position, this part can be utilized as the dumping of the overburden material, at this position, or we can directly dump it like this also. Okay. And in that case, this is our pit. So, this is the overburden dumped rock that will allow us to go for backfilling of the area, and we need not to have so much land acquisition in this case. So, that is the benefit of this backfilling, and to exercise this backfilling, in that case we have to go for external box cut. So, that external box cut is possible if we are having a bedded deposit and we are opting for the backfilling technique. We can have multiple box cut also. That one box cut at this position, another box cut at this position, and we will allow our movement of the benches in this direction and gradually in this direction also, that will also move towards this direction. So, gradually we can have this type of system. In case of multiple box cut, that is basically increase the, if we are having multiple box cut, it increase the production rate. So, our development will be faster, and that is the importance of the multiple box cut. So, often we can go for the multiple box cut also using the more number of machines. So, in general we say in this vent type of deposit also we can go for the internal box cut, and the choice of whether we will go for the internal box cut or external box cut depends on the shape of the deposit, say massive, hill, etc. we go for internal box cut. Size of the deposit, for the extensive bedded deposit we can go for the external box cut also. Deep of the deposit, then we can go for, if it is high we can go for the outside, if it is outcropped we can go for in the ore itself. Thickness of the deposit, for thick it is internal, for thin we may go for the external. Grade of ore, then economic criteria. Okay. So, all these things, our economic criteria is that we should get the start the excavation, that is the reaching to the deposit should be as early as possible, and that is why in most of the cases we go for the internal box cut, because that is allowing us to reach the deposit at the earliest. So, that is the benefit of the internal box cut. The way of excavation of the box cut is also important. If the material is soft, generally excavator can dig it out easily. We will come to that part at a later stage. First, let us discuss if the material is very hard, in that case the excavation technique can be adopted is the drilling and blasting technique. So, in drilling and blasting generally we can have vertical holes, we can adopt the incline hole also, and this is the length of hole is decided using this criteria, where height is the proposed bench height, beta is the drill angle, sub drilling is to be avoided for sub drilling is carried out to avoid the toe formation. So, this is the general concept of determination of the length of hole for drilling and blasting carried out in a box cut, and this is the selection of the burden, spacing, sub drilling for the depending on the strength of the rock. This criteria is the Lange-Forss-Kristrom criteria for the drill diameter and bench height relationship, it is given for both the cases based on this. So, this is Lange-Forss-Kristrom criteria, what will be your burden, spacing and sub drilling if your bench height is less than 100 d, if your bench height is more than 100 d, this is the relationship, and this is the rock strength, and otherwise you can adopt the burden value for this case, you can adopt the equation this model for calculation of the burden for this case. Okay. So, this is the Lange-Forss-Kristrom guideline for carrying the blasting, and this is the pattern in general followed in a box cut. So, this is for the ramp part, up to this is for the ramp part, and here the drilling length is depending on the ramp height you have to maintain. So, this is the drilling length. As there is no free face, in general we can go for a wedge cut drilling system, and if it is a hard rock is available, very hard rock case, we can provide a pilot hole of short length, so that an initial excavation is created. At this place, that will act as the free face for the rest of the wedge part, and this is the system we can follow, wedge cut blasting system. You can see these holes are inclined towards this direction, these holes are inclined towards this direction. This is the general blasting pattern carried out for the wedge cut excavation. This part, as the height is not significant, it is not very significant for carrying out drilling and blasting system here, the excavators are strong enough to dig this one once the blasting is carried out at this position. So, excavator can dig this part of rock with this bucket strength bucket teeth. So, this is the common general drilling and blasting pattern for the wedge cut. That is in general practice for a strong rock, but you remember in most of the cases your box cut is the first initial cut. So, box cut is in general placed in the top surface. So, as it is in the top surface is more or less soft formation. So, drilling and blasting system may be required for a little bit depth. So, if soft surface is available, that can be excavator can be used for excavation of that one. So, that is very commonly used method. We will come to that, we will see the video of that in the next lecture. So, let us stop this lecture at this point. Thank you.